pretty much at the same time. That's what makes these rounds so fast, because a bullet ignites at the bottom and then it explodes and does that, and that's why you get that. This thing is, through the shell, which the shell itself is probably, it's doing it at the bottom, because it's only like a foot, 11 inches up into the shell. So there, boom, it shoots all that flame out, and then everything takes off. And it propels a projectile at somewhere around 5,100 feet per second, which is just absolutely incredible. They tell me that the pressure, the actual pressure, because they took the cordite and, tested it as far as what it was exerting on the hull as it came out on the thing, was 3,000 psi. So it's over-engineered by 5 to 1. It's over-engineered. So if it passes the 15,000 psi, and the way they do it now is they do the whole thing, assemble it, then they take it over to this test area. The guy screws it on, screws it off, screws it on, screws it off. It's being made up in Chicago at some little small machine shop in Chicago. But that would be, if you can get, technically, put all that stuff on a machine and do it in that manner. That just, was so much faster. And I just don't know where they're at on it. Don't know what they're doing with it. But there's other opportunities like that in military type things. There's other opportunities like that in there for us to build other types of products using your lathe and your mills in there. Now, we did not discuss, so we got the size range there, and I definitely would like to see the equipment. You're not wanting to deal in any of the aerospace type materials like the Inconels or Hastelloys or anything else like that. Am I correct on that? You wanted to stay away from that, or is that okay?
I haven't dealt in that. When we were doing aerospace, a lot of the material was investment castings, and it didn't require those specifics that you have just explained. I would have to look up some of that material to see. I've just been entertaining a few quotes coming through with titanium. I looked at that stuff, and I really don't want to deal with that. But so some of the ones that you just explained, I would have to look up and see where we are in that. I'm not familiar with it.
Yeah, Inconel, Hastelloy, Carpenter 20, Carpenter 49, and another phase which is called multi-phase, and that is a SBS Dow creation, MP35N and MP159. MP35N is 35% nickel, 35% cobalt, and then chromium and vanadium make up the other 30%. So it's 35 nickel, 35 cobalt, and then equal shares of what would that be? 15. I think it's like 15% chromium, 15% molybdenum, and then 15% vanadium. And that's a nasty metal. I mean, that's a nasty metal. But some of those things are used in commercial applications, specifically around high pressure or acidic environments, where you have a very corrosive environment, and those things. But you're going to be looking more for general machining type opportunities. What is a close tolerance for you? I mean, are you looking to go down in milling? Are you milling in the like one plus or minus 1,000th in a milling application, or are you going tighter than that?
There's some opportunities there for turning that we go to total tolerance of 1,500, which is plus or minus 0.7, 50 millionths. So, and that in the turning application, because there's a Boeing process in there, and then there is in the milling application horizontal, there is tolerance that runs the same, maybe